Hello class, this is Mr. Matthijs. This video is going to be the beginning of chapter 11, which deals with game theory. Okay, so what is game theory? What is game theory? Game theory is one of the newest branches of mathematics. It first came to light when a brilliant mathematician named Dr. John von Neumann co-authored with Dr. Morgenstern a book titled Theory of Games and Economic Behavior. Since then, it has played an important role in decision-making in business, economics, social sciences, and other fields. Another name that often comes up when we're talking about game theory is Dr. John Nash, who is the subject of the film A Beautiful Mind. He was also a mathematician interested in the field of game theory. So this is a field of mathematics. When we talk about business, economics, social science, especially like mathematical modeling for interactions between people or entities. So in this chapter, we're going to study games that involve only two players. In these games, since a win for one person is a loss for the other, we refer to them as two-person zero-sum games. Right? So two players. Zero-sum means if one player wins $5, the other player loses $5. So overall, 5 plus negative 5 is 0. That's what zero-sum means. We're going to start with simple games, but they'll kind of lay the foundation for how these games work, and we'll see how they can be applied to the real world, like business, economics, and social sciences, and other fields. In this section, we're just going to talk about strictly determined games, and then later on in the chapter, we'll look at other types of games. Okay, so this is the first game we're going to talk about. Robert and Carol decide to play a game using a dime and a quarter. Each chooses one of the two coins, puts it in their hand, and closes their fist. At a given signal, they simultaneously open their fists. If the sum of the coins is less than 35 cents, Robert gets both coins. Otherwise, Carol gets both coins. Write the matrix for the game. Determine the optimal strategies for each player and find the expected payoff for Robert. Okay, so we've got a pretty simple game. Just a coin picking game with two players. And since it says find the expected payoff for Robert, right, we're going to kind of consider the values of the outcomes of the game from Robert's perspective. So the way that we're going to model this is with a matrix. So we're going to have Robert be represented with the rows, and Carol will be our columns player. And they both have two options, either a dime or a quarter. Right? So those are the possible options for each player, is to either show the dime or the quarter. And then let's think about the outcome. Who wins the game depends on the sum of the coins. If the sum of the coins is less than 35 cents, Robert gets both coins. Otherwise, Carol gets both coins, right? So if Robert shows a dime and Carol shows a dime, then the sum of the coins is 20 cents, which is less than 35. So Robert would get Carol's dime. So Robert would gain 10 cents in that scenario. If Robert shows a dime and Carol shows a quarter, then the sum is 35 cents. So since it's not less than 35, that means that Carol would get the coin. So Carol would get Robert's dime. So again, from Robert's perspective, Robert is losing a dime. He's losing 10 cents. And then let's think about if Robert shows his quarter and Carol shows the dime, then again, that's a 35-cent sum. So the sum is greater than 35 cents, so Carol gets the coins. So Carol would get Robert's dime, meaning that Robert would lose 25 cents. And then if Robert shows his quarter and Carol also shows her quarter, the sum is 50 cents. That's not less than 35, so Robert isn't the winner. Carol would be the winner. So in that scenario, Robert would also lose his quarter. Okay? So this is the matrix for the game. There's 4 possible outcomes, and each of those has a value for Robert, right? So let's determine the optimal strategies for each player. Let's look at Robert, right? We see that if Robert plays his quarter, he's going to lose. Either way, he's going to lose that quarter, right? There's no way that he plays the quarter and the sum is less than 35 cents, right? If he plays the quarter, whatever Carol plays, the sum is going to be 35 cents or more, so Carol's going to get his quarter. So for Robert, the dime is the optimal choice for Robert. Right? And now let's look at Carol. If Carol plays her dime, right, there's a chance that she could lose. There's a chance that she could have to give her dime to Robert and lose 10 cents, or there's a chance that she could get Robert's quarter. But if she plays her quarter, no matter what Robert plays, she's going to get Robert's coin, right? If Carol plays the quarter, no matter what Robert plays, the sum is going to be 35 cents or more, so she's going to win. So Carol's best play is to play the quarter, right? That's her best. That's her best option, is to play the quarter. She's guaranteed to win at least 10 cents, if not 25, right? So those are the optimal strategies. And then the expected payoff for Robert, right? If both players play their optimal strategy, Robert expected payoff is to lose a dime. To lose 10 cents. Okay? So it's not a very good game for Robert. If Robert plays his best strategy, he's going to lose 10 cents. He could play a different strategy and do even worse than that, but the best that Robert can do is losing only 10 cents. Okay. So that is what's called a strictly determined game. In the above example, since there's only one fixed optimal strategy for each player, regardless of their opponent's strategy, we say the game possesses a pure strategy and is strictly determined, right? Each player had, of their options, one of the options was better regardless of what the other player did, right? Their strategy, what they should do, is strictly determined. It doesn't depend on the other player. Okay, so what we're going to see next is a method to find the optimal strategy for each player and the value of the game. The method involves considering the worst scenario for each player. Okay, so this is the strategy, and this is really the big slide for today. If you pay attention to anything, this is the slide you want to pay attention to. Finding the optimal strategy and the value for strictly determined games. Okay. The first thing you want to do is put an asterisk next to the minimum entry in each row. In each row, find the minimum entry and mark it with an asterisk. Then put a box around the maximum entry in each column. In each column, find the maximum entry and put a box around it. Then, the entry that has both an asterisk and a box, find the asterisk and the box. That entry represents the value of the game and is called the saddle point. The row that is associated with the saddle point represents the best strategy for the row player. The column associated with the saddle point represents the best strategy for the column player. It is possible that the game matrix can have more than one saddle point, but all the saddle points will have the same value. So all the saddle points will be the same. If no saddle point exists, the game is not strictly determined, and that'll be the subject of the next section. So right now we're just looking at strictly determined games. So let's go back to our Robert and Carol example and use this step-by-step strategy to see how that works in this example. Okay. Okay, so step 1, put an asterisk next to the minimum entry in each row. Okay, so let's look at the rows. Okay, so negative 10 is less than 10, so that's our asterisk. And then in this row, they're equal, so it could be either one. Then we'll put a box around the maximum entry in each column. So this is the maximum entry in this column, and this is the maximum entry in this column. Right? 10 is more than negative 25. Negative 10 is more than negative 25. Okay. Now we find the entry that has both the asterisk and the box. So that's this entry right here, negative 10 here. That's our saddle point in red here. Circled in red is our saddle point, right? So that's called the saddle point. So the saddle point tells us a lot of the information that we're trying to figure out, right? The row, or before we get to the row and column, this represents the value of the game, right? So the value of the game is negative 10 cents because that's the saddle point. And then the row associated with the saddle point represents the best strategy for the row player, right? So the saddle point occurs in Robert's dime row, so we can say the best thing for Robert to do is to play the dime. And the column that is associated with the saddle point represents the best strategy for the column player. So the saddle point is in Carol's quarter column, so quarter's best option is to play the quarter. Okay, so that gives us the best strategies. Right? In this case, there's only one saddle point, and since there is a saddle point, we can say that it is a strictly determined game with a value of negative 10 cents and with an optimal strategy of Robert playing the dime and Carol playing the quarter. Okay, so let's do another example of just using the same process to find the optimal strategies and the values of a game. Right, so in this example, we've just got a row player and a column player. And so we're just trying to find what's the best strategy for each player and what's the value if they both play their best strategy. Okay, so step 1, put an asterisk next to the minimum entry in each row. Okay, so we'll go by each row. In the first row, negative 25 is the lowest. Negative 25 is less than 10. And then in the second row, 10 is less than 50. So that's the minimum entry in the second row. Okay, step 2, put a box around the maximum entry in each column. Maximum entry. Okay, so in the first column, 10 is greater than negative 25. And in the second column, 50 is greater than 10. So those are our boxes. Okay, step 3, find the saddle point. The entry that has both an asterisk and a box represents the value of the game and is called the saddle point. So that's, of course, this entry right here, this 10 with the box and the asterisk. So we can say the value of the game is 10. $10 or 10 cents or whatever. It doesn't really have units. And that comes from the saddle point that we've circled here in red. And then we can find the best strategy by looking at the row and column of our saddle point, right? So the best strategy for the row player is to choose the second row. And the best strategy for the column player is to play the first column. Not really told what the options are, but whatever option for the row player is the second option, and whatever option for the column player is the first option are going to be their best or optimal strategies. Okay, so that's pretty much all there is to it for strictly determined games. Yeah, so for homework, just go to the next page, page 388, and do 1 through 4. Again, if you just go back to that main slide with the step-by-step how to work through these game matrices. That pretty much sums it all up. If you have any questions, don't hesitate to send me an email. Good luck.